Good evening. Ooh, it works. Hello, if you're joining us from the internet. You might be joining us from the internet because I understand it is reading week at the University of Ottawa. Is that correct? So maybe you just couldn't miss us and you spent your evening tuning in, which I really appreciate. We are OWASP Ottawa, and we have been doing this meetup here at the University of Ottawa for feels like forever, which is great because we've built a fantastic community here. Thank you for coming out. Who here has never joined us before? Awesome, new faces. Who has never heard of OWASP before? All right, that's good overlap, which is that there is none. So the meetup here is usually full of pizza. Reading week, the pizza took off. So apologies for that. If you were planning on supper, we'll try to move quicker this evening than usual and we'll figure out a different solution. I did try to go for Timbits. Tim Hortons also closed. So we're all out of luck. A couple of announcements when it comes to OWASP Ottawa. We'd love to stay connected. So again, if this is your first time, we have a Slack channel. You may have seen a QR code up there. If you haven't, talk to one of the organizers. If you're an organizer, could you put up your hand? There we go. That also gives me an opportunity to, and Given Central Dan did not put up his hand, I think he is considered part of our crew. He's also our sponsor here at the University of Ottawa. Thank you, Doctor. When it comes to OWASP Ottawa, we are a welcoming, inclusive community. All levels of experience are welcome here, and it's been fantastic to see some great stories of folks who have joined our community and found new interests and found new skills and grown from that. Harsh has a really interesting story, and he'll probably share more of it this evening. I'm not going to go into all the details, but Harsh was going to build robots. When it comes to Harsh's deepest interest, he believed it was going to be robotics. And then he wound up getting involved in cybersecurity and very quickly realized that that was something that fit his interests and his skills. And he made a huge pivot, which I don't like the pivot. You like added on, you took a new direction in your journey. And is now 3 years into a career as a cybersecurity consultant at Software Secured here in Ottawa. How many people here love VPNs? Okay, it's not nobody. How many people here might rely on a VPN for some level of security to secure some, right? Having managed controls or relied on VPNs as controls before, I always love when a new CVE comes out and we get to think, well, what does this mean for us? Well, Harsh asked that question, and he's going to tell us a little bit about what he discovered when a new CVE related to VPNs came out, and he had a client who wanted to learn a little bit more about that. So that's what we're going to talk about this evening. If you do have any questions about OWASP Ottawa, about the talk, or about anything else in our community, I'd love to chat. Garth, Mel, Harsh, all organizers would also love to chat. There are lots of other fantastic organizers who help us as well. Thank you. Without further ado, did I get it all? All right, I'm going to hand it over to Harsh.
I can start sharing, right? It's already there. Hello, everyone. So, like Adam introduced me already, my name's Harsh, and we're going to be talking about a VPN bypass that sounds severe, but is it actually? We'll see more about it. So, who am I? I'm someone who is an application security consultant at Software Secured. Software Secured is a company that's based out of Ottawa. We help like small to established businesses meet their security goals. We perform penetration tests, secure cloud reviews, code reviews, and so on and so forth. I hold a master's degree in electronics and electrical and computer engineering. That's why the robotics background came in. And other than that, I like to ski, do some photography, make illustrations, and go mountain biking from time to time. So if you have any of those interests, I'm open to making new friends. All right, so we'll get right to it. This is how the talk's going to go. So I'm going to give you a little bit of primer where I'm going to be talking about the basics that you might require or need to brush up to understand this vulnerabilities, because it's going to get a little bit technical, but it's not that hard to understand. All right. So the first things first, like how do you connect to an internet? Normally, you would just open up any of your device's Wi-Fi settings. You would connect to a network that you already know and you know the password of, and that's it. You click, and then you have access to the internet. But what happens inside is quite different. It's not that simple. So whenever you connect, the router wants to communicate with you. A router is something that is connected to your ISP, which is your internet service provider, that gives you access to the internet. And whenever you connect to the router, it does not know who you are other than the MAC address that's provided, that is of your device. So how would it recognize you, and how would it basically try to send the traffic that's intended for you? There are so many other devices that are connected to the Wi-Fi router as well. So how does the router know that you have requested google.com and not your neighbor? So that is where IP addresses come in. So a router basically assigns you an IP address. So any of the traffic that you send and the response that you get from the internet or any other network is intended for your device. And in this case, the underlying mechanism is called DHCP. So we're going to be talking about what DHCP exactly is. It's an abbreviation for so DHCP is basically a mechanism which allows you to set IP addresses to a given device. And this is done basically when a device connects to a network and it sends out a DHCP discover request throughout the network. It doesn't have an IP address at that point. And if there's a DHCP server present in that network, it sends out a DHCP acknowledgement request, and basically saying that I am the DHCP of this network. This allows the client to actually send a request to the DHCP saying that assign me an IP address. And the DHCP does that, and that's it. That's how DHCP works. Also, one more thing is that DHCP server has a limited amount of IPs that it could assign. This is configured by the network administrator, or there's a default config of 256 IP addresses. 255, the one of the addresses being the gateways. And then comes the part of routing tables. So what are routing tables? Routing tables are a set of rules that basically guide your traffic to a network, to a destination network. And in this case, their definition, this is what a generic routing table looks like, where we have the network destination, which is your intended destination network IP range, and the net mask is basically the CIDR notations represented in a different way. And gateway is, in this scenario, would be your router, and through which two networks are connected. Interface is basically your port, not exactly the ports, but the interfaces of your Wi-Fi, or if it's Ethernet, if you have like 5 Ethernet ports, then it will be like five different interfaces. And metric is where you decide the priority given to a specific route. So the lower the number, the higher the priority that the route would have. And this is where exactly the vulnerability takes place, because TunnelVision basically exploits the routing table. And that's why this is important. So there are two types of routing. One is static routing and one is dynamic routing. Dynamic routing is taken care of by the router. So it sets up all the paths that you want, that you require to connect to a specific destination. Static routing is when you manually enter those paths or are manually enter those paths, or they are designed to be entered directly, and it does not have any interfaces connected to it. So what is a VPN? This is, I think everyone's aware of what it is. So it's a virtual private network where um, your device basically your device has a VPN client where you click connect, and that's when the VPN says it's connected to a specific server. That is your client. So the VPN client basically connects you creates a tunnel between a VPN server that's on the internet. And after that, whatever the traffic you send goes from your VPN client to the VPN server directly. And even though it uses the actual cables and the wires and whatever the internet backbone is, but it's all encrypted. So nobody else other than the client and the server can understand what's going on. So even if you say you wanted to go to google.com or browse a Russian site from USA or like Ukraine or something like that, nobody on the internet would know that you were visiting such sites because it's going to be requested by the VPN server and not you. So, and also the thing is that there are public VPNs and there are private VPNs. Private VPNs basically act as your personal VPN. No other traffic comes out of that VPN. And in public VPN, what happens is that whenever you're tunneled to a public VPN, there are like multiple connections into that same server, and there are multiple requests going from that same server to different addresses. So in that case, you get more privacy. So that's how VPNs work generally. Any questions so far? Okay. Okay, yeah. I'll wait. Nice. It's a snack break. Yeah.
So the information that you send through your router gets encrypted on the VPN too.
So the communication gets encrypted in your own computer, and it's sent through your router. So the router doesn't know what's going on. It only knows that you're contacting the VPN server. That's it.
So there's an additional layer of encryption there between.
Exactly.
Okay. So when you buy access to a private VPN,
Yeah.
do they give you, or it is a specific key installed on your device that?
It comes with the client. Whenever you log into your account, they have a specific key for you, and the server has this other key, like the public and private key in the server. So that's how it normally works. And just, I mean, this is out of topic, but then again, public VPN servers are better if you're looking for OPSEC stuff, but sometimes they're mostly blocked by most of the firewalls because everybody knows the IPs of the public VPN servers. So if you're into OPSEC, it depends on what kind of things you do, but this is like extra information. So yeah, so that's about it. And TunnelVision, now we're gonna start understanding what this CVE is. So this basically, TunnelVision is basically a vulnerability or a technique that allows any of the VPN traffic be subverted from the tunnel. So none of the traffic, you have a tunnel that's already there, VPN connection's been established, you think you're secure, but the traffic is actually rerouted to the normal network rather than sending it through the tunnel. And this is where the DHCP server comes into the play. So in 2002, because of an RFC 3442, which introduced like option 120, one for like static classless routes. What it does is basically allows a network administrator to assign classless static routes on your DHCP server. There's this option on your DHCP server to do it. So basically, you can. There's no limit besides packet size to how many different routes can be installed at once. And the one thing about this attack, one special thing about this attack is you never know that you're actually being attacked, because like you still think that the VPN connection is intact. I mean, there are mitigations for it, but when it came out, there weren't any. And most of the commercial VPN providers were actually vulnerable to this. So I know, yeah. So classless is when you don't have the CIDR notation given to the route. So normally, if you see this routing table, you can see the net mask, right? So the net masks are not given. So it's not a specific IP address. It could be a range of IP addresses or something like that. So if that's not there, there is no priority set for it, and it's always going to be the top priority. Yeah. So when these routes are set, they supersede any of the other routes that are there in the routing table, and that's where this attack happens. So generally, this is a low severity. People were panicking about this back in May because nobody knew what it was, but this is only possible if somebody has access to your Wi-Fi network or your network and is able to basically take control of the DHCP server there, or is able to perform a starvation attack on your DHCP server. What is a starvation attack? Remember when I said that DHCP has a specific range of IPs that it could assign? So what ends up happening in a starvation attack is an attacker will basically create a malicious bot that will flood the network with DHCP discover requests. That means that now all these IP addresses are assigned to that one machine which has flooded the request. So those 255 IP addresses are gone, right? So now what the attacker can do is he or she can set up their own DHCP server, and then push configs, assign IPs, do whatever. So this is a low severity because the exploitability of this is like super low. Reproducibility is also low if you know what CVSS is. And yes, so they have to be in your network, and then they have to perform all these attacks, which is also, if you're a network administrator or do those kind of stuff, it's easily detectable. The reason why this was considered a CVE, because this was to give information to the general public using the VPN providers and putting full trust. It can be a vulnerability if like people say that our network is 100% secure, your data is 100% secure, and it does not like leave. Then it's a vulnerability. If the VPN providers don't claim that, this is just a technique that attackers can use. So yeah, that is how it basically works. So the to attack it, the complexity is too high, and it is detectable. But to a general public who are just using their VPN provider commercially, this can yeah.
So once they get into your network, is it easy for them to do the same thing regardless if it's like a public or a private VPN, or is it harder with a private VPN?
So it really does not matter because the attack happens in your network.
Yeah.
So the public VPN server or the private VPN server, it's a VPN provider's.
So even if not skip,
Yeah, it doesn't matter. And it depends on the type of VPN services you're using. Most of them are patched. So I basically tried Proton VPN. I tried NordVPN. They have this default setting that blocks this. But back in May, nobody had it. They had kill switches, but they were not on by default. So we'll talk about the mitigation soon. Yeah. So any other questions regarding this? Yeah.
So my understanding is that with the VPN, you're not telling, you're not selling on the line that you want to go to YouTube.com. You're selling on the line that you want to go to the VPN server with information.
Yeah.
How is it that an attacker would be able to read that you want to go to YouTube.com, for example, to add that?
So the thing is, here we are basically messing with the routing table. I'll show you the explanation in the data flow diagram, like the traffic flow diagram. Okay, so there we are. I think that's, yeah, there you go. I don't know if you can see it, but I will just explain it. Yeah. Yeah, it is very small. I'm sorry. But I can just read it out for you, and probably you can follow. I'm sorry about this. So basically, you have this user application, and then the user application sends a payload to your socket. The socket then sends that payload into a routing table. This is the configuration of a general VPN when it's like functioning normally. And then you have this TUN0 that is the interface of the VPN. This is where when you create a tunnel, when you create or connect to a VPN server, a tunnel interface is created, and TUN0 basically forwards the traffic to your network interface, that is your TUN0, and which writes it to a file descriptor in Linux, and it sends it to the VPN client where there is an encryption key. Here, your data is encrypted and sent to the socket, back to the routing table. Now it has to get outside the network. That's why it's sent to the routing table again. And then it goes to your route of the internet. That is your gateway. That is the LAN interface. And then it goes to your network interface. Then it goes, then makes its way through the Wi-Fi driver, and then Wi-Fi, and then goes to the internet, VPN server, and it comes back with the response. Response packet goes back to the Wi-Fi NIC, the Wi-Fi driver, the LAN interface, and then comes back to the firewall rules, goes to the tunnel, comes back to the socket, is going back to the VPN client where this entire data is decrypted, file descriptor, then we go to the tunnel interface, and then it goes back to the socket, and then to the user. So this is how a general VPN flow works. So as you can see, any questions regarding this? Or like, was I not?
Is the type of interface relevant, like whether it's Wi-Fi or Ethernet?
No, it doesn't. It doesn't really matter. It just changes the network interface, basically. Yeah. So this is how a VPN flow works. Sorry about the small fonts. And when you tunnel visioned, basically you've exploited this, what ends up happening is that your the data, the packets basically ignore your TUN0 route. So even though you have a connection from your VPN client to the VPN server, it just does not, it just ignores it, like it's not there. And then it basically, using the DHCP's protocol of Route 21, it just goes through the LAN interface and directly just goes through the internet unencrypted, and then comes back unencrypted. And then basically that's how the VPN bypass works. Yeah.
So if I understand this correctly, so when that is going to zero, that routing table is internal to the device, or is that like your actual, or is that like the actual router that's on?
It's on the router. Yeah, it's on the router. Yeah.
So is the packet like firing off?
This also changes inside the router as well as your own device.
Okay.
Yeah.
So there's stuff that like basically.
Yeah.
What's going to TUN0 is basically just like that. Hey, we put this.
Yeah.
Traffic, and then when it goes through around the second time, that's what the actual data is. Do I have that correct?
In this case, when the exploit is taking place?
Like
In the beginning one,
in the
yeah.
happy path.
Yeah. So basically, it goes to the internal tunnel interface. That's a virtual interface, which is connected to the VPN client. That's where the encryption happens. And what happened? Yeah. Okay. So that's where the encryption happens, goes through the normal route to the internet VPN server, decryption, and the VPN server encrypts it, makes it go back to the VPN client, decrypts it, and wherever you requested it, that data is sent to that application. Most of the cases, it's the browser. And another thing that I wanted to mention was, another thing that the main part of this is that Android is not vulnerable to this because Android ignores the RFC option 121 altogether. So you can't really exploit it. Even if you have a DHCP option that pushes a route using option 121, it'll just ignore it. The main things, most of the applications or the OSs that were exploitable were in Windows, iOS, and Linux mostly. Windows was secure if you had firewall enabled on your network. So any questions so far in terms of understanding the, yeah.
So you said Android, right?
Yeah.
It's like a flavor of Linux?
Yeah.
So is it just that flavor of Linux, or what's special about Android?
They just decided not to implement it on that operating system. They just ignore it. And the thing is that option 121 is used for actual technical requirements in certain applications. And there is a debate between developers and Android and Google saying that please introduce this so we can make our applications work in Android too. So this is not like, it's actually a feature that people want to be enabled, but people can also exploit it like this if you don't have the right security controls. So yeah. So now here's the time for the demo. So in this case, the demo has been simplified to a, yeah. No. So the DHCP server exists in a network. So each network has 1, 2, 3 DHCP servers depending on the technical requirements. Yes.
I mean, if you think about it this way, a DHCP server is like, hey, I need an IP address for this now. You can't. That's essentially what a DHCP
Yeah.
is. Well, that's what someone making a DHCP request does. And DHCP server is like, okay,
Yeah.
Here's the
Special server.
Yeah, exactly.
Yeah.
So
Every network has its own DHCP server.
So,
Yeah. It runs on the router all the time, most of the time. But in this case, you can also set it up outside the router too. You could there's an option in your router to disable your DHCP server, and then you could create your own in that network, and then you could start assigning stuff. Yeah, assigning people IP addresses. Android. So basically, whenever an Android device connects to a rogue DHCP server and it gets that option 121 and it gets a route, it just ignores it. Whenever the routes are set by the DHCP server. So when Android connects to it, it just ignores that line because it doesn't care. It doesn't have that option. Yeah, there you go.
So Harsh, fundamentally, my DHCP server needs to be owned in order to.
Yes. Yeah.
And there are many ways you might own my DHCP server.
Exactly.
If I have
Exactly. Yeah. So if an attacker gets into your network, that's the biggest problem rather than this attack. That's why this is a low severity attack. So yeah.
But I might assume on my network that it's okay if I'm network zone, I got to get access.
Yeah, unless you have a friend who has malicious intent. There you go. Yeah. So yeah. So basically, I've created a demo which is like super simple. It'll help you understand the entire thing. But here, I'm not doing any starvation attacks. I am not creating a. I've basically created a DHCP server that's rogue, and the router DHCP server is limited to just 2 IP addresses. Why I did that is just for simplicity, because I want my attacker machine to be connected to that specific Wi-Fi, and there's a virtual box inside that attacker machine which gets another IP. So I only given 2 IP addresses that are available to be taken. And so it kind of simulates that the router's DHCP server does not have any more IPs to give out. So it kind of is like a starvation attack. Well, not a starvation attack, but it simulates one in this scenario. So now we don't have a DHCP, like a working DHCP server in our network. That's the assumption we're gonna keep in this specific demo. And here, I'll be switching between two devices. One will be our DHCP server, and then the other will be the victim machine. And in the victim machine, the DHCP server will also show some configs. There'll be small fonts. I'm really sorry about that, but I'll try my best to read it out to you. Yeah, it's pretty small. Yeah. Does it not go full screen? Oh, God. Oh, no. Oh, shit. F11. I'm sorry about this. I'm so sorry about this. I expected it to be bigger, but anyway. Huh. Let me try. No, it just, yeah, it just makes the UI bigger. Yeah. Okay, so I don't think you'll be able to understand much here, but it's all gibberish. But what I was trying to show was the first one. The first one is a cat of a DHCP config file, and there was a RFC option that I put in the config file that has a specific route, and that route is going to be pushed. And then there's another config file where there is a route. There is no route. It's like a normal config file. So in this case, this is an attacker machine, and right now the configuration is more like a normal DHCP server. I think this works. At least this is clear. Yeah. So, oops.
Maybe what I'll suggest is when you finish the rest of your talk, you can show the demo to individuals at the podium.
Yeah, sure. So here you can see that I'm doing a trace route to a Google DNS server because like I have specifically given the DHCP server's configuration to divert all traffic from the 8.8.8 to a different to a normal route. So basically, even if the VPN is connected, it's just going to go. It's just going to ignore the VPN tunnel. So I'm just not going to show you my IP address. That's why there's a black line there. Yeah, I don't want to know where you guys live. So where I live, so no. So here, as you can see, this is a normal internet connection. There is no VPN involved, nothing like that. And it's going through montrealbell.ca. So it's basically going through the Canadian network. This is how the packets are traveling. Now what I'm going to do, I just downloaded a free VPN. It's called Planet VPN. Don't do it. And it's not secure. This is just to show you guys. This is going to go through Paris. And we're going to send the same command. Traceroute basically tells you the path that all your traffic takes to reach a specific server. So here, as you can see, the ping is already higher. It's 172 for 45 milliseconds. And back then, it was like less than 1 millisecond because it was connected to my own router. So now, as you can see, it's ponytelecom.eu. So all the packets are being routed to European servers. So that means that the tunnel is secure and like all your data is going through the tunnel. No, this is how it was. This is how slow it was, yes. Yeah. So it takes a while to finish it. and finally reaches the server, but it takes a long time, and this goes to show that it is actually using the tunnel. But now we will then push the malicious config into our DHCP server, which assigned this IP. And here we are basically releasing our DHCP connection, DHCP lease. So DHCP also has this lease time option that after 60 minutes, you come back to me, I'll assign you a new one, a new IP address, or I'll renew the same one. So you can also configure it to be just 5 seconds. Attacker can like configure it to be just 5 seconds, and so it keeps on doing this. So you don't have to really put that command in manually to release your DHCP connection. So here I trace routed 8.8.8, which is the Google DNS, even though the VPN is still on. And as you can see, it's not actually going to France. It's just going to the basic route that was already going through. So it's not even using the tunnel anymore. So yeah, it's going to take its time. As you can see, it's still taking the Montreal route. So yeah, this is basically how the VPN is bypassed. Yeah.
If you're able to redirect past your VPN's tunnel, are you also able to redirect to a malicious server that's pretending to be another node on the network?
Yeah, 100%. Yeah.
And if that happens, are you able to use that to own your own personal device? Because so far, the DHCP server for your router is up.
Yeah.
Can you then use that as an export to get to a personal machine?
True, but then that's another form of MITM attack. This is basically an MITM attack. MITM stands for man in the middle attack. So that's another form. But yeah, you surely can, because you're basically diverting all this traffic there. And if you have a certain configuration set up in that specific machine or the malicious machine, you can for sure.
But Harsh, the does actually, the implication here is that because you can bypass the tunnel, I can now sniff every packet that you sent out.
Exactly. Another reason why this is a low severity, because like the general public would normally browse their web browsers or play video games or stuff like that, right? So everything is HTTPS nowadays. So it's all encrypted. So all they're gonna know at this point is like, what sites are you visiting? What you're doing on that site, nobody would know. If you're using any other insecure protocols and you're using it on the internet, they will surely know exactly what you're doing there. Yeah.
There's also the consideration that I think, like, I forget like what the actual acronym is, but I think like an encrypted variant of DNS also exists.
DNSSEC, yes.
Yeah, DNSSEC. So if the network is, or if the host on the network is using that, this entire attack is useless.
Exactly. So there are lots of mitigations for this. And yeah.
If I am using SSL, I should assume that my traffic is secure unless there is some other vulnerability that I'm also, like, again, thinking about a generally like fairly insecure consumer, essentially. There may well be a few chains of attack here that they're vulnerable to in the wild.
Yeah.
That maybe reasonably, but even though like yes, they're public, there's a couple of affiliates here.
Yeah. So, and also the thing is like, this is, if the government is after you and like trying to figure out what you're doing on the internet, they could literally just contact the VPN providers and then get your data. Yeah.
And I've been able, like, I have some other reasons that I want to harm you.
Yeah.
And it's good for me to know
What sites you visit.
where you're going.
Yeah.
That's enough for me to harm.
Yes.
There's no.
Yeah. That's the exploit or a feature, because like normally if somebody is already in your network, then you have other bigger problems to deal with, because like how did they get access to that network, right? So yeah, that's that. Any more questions before we get into mitigations? Okay. So mitigations are quite simple. Most of the VPN providers already have implemented their mitigations. They're on by default these days, so none of the information gets leaked if you use providers like Proton VPN, NordVPN, or stuff like or similar providers of that stature. And if you don't have those, or if you have your own WireGuard configuration or something like that, you could always use firewall rules that basically force all the outbound and inbound traffic to use your VPN tunnel. You could also use, yeah, okay. You could also use, you could also configure your network for DHCP snooping. This basically, DHCP snooping does not allow unauthorized DHCP server to assign IP addresses to the devices in that network. Another thing would be to disable or ignore 121 on your DHCP, option 121 on your DHCP clients completely. But this might break functionalities because like some devices like Starlink and other technical, if it's technically required in your network to have option 121, it might like completely take out your internet connection. And the other option would be the kill switch option that's mostly provided in good, like high quality or like a standardized VPN providers. They have a kill switch saying that if any of the data does not go through the tunnel, it'll just kill the VPN connection and internet connectivity completely. So in terms of how severe is this? Not really. There are lots of mitigations towards it. Is it a vulnerability? And it depends on who you ask, because I personally don't think it's a vulnerability. It's more like a feature, because like if you can, if RFC says that you could actually put routes somewhere, and that is the intended functionality, and if your network infrastructure is already insecure, then this is basically like them MIT and using the MITM on that network. So they could also perform not just this, but lots of other attacks if they're already in your network. So yeah. That's about it. Thank you very much.
Thank you, Harsh.
Yeah.
Now, we've had a number of questions through that, but let's just one more minute. Any more questions about this vulnerability or Harsh's experience trying to figure it out? We didn't get a great resolution on the walkthrough, but is there anything else that everybody wants to clarify? I'll get back here to you.
Yeah, so can you really hospital the situation that mother in my own network being abused?
Yeah.
My data server. But I think that the real problem with this attack is every time you're out and about and you try to come this is an open Wi-Fi or a hotel or anywhere but your network. Most of these people sitting here, except the restaurant. But I don't think it's knowing what to do or not.
Yeah. Yeah.
But otherwise, what do you do if you are not at home and you need to connect?
The best thing would be to carry a travel router whenever you're connecting to Actually, that's a mitigation for most of the vulnerabilities out there that could be exploited on a public network. So there are small travel routers that you could just connect to a USB-C port, and then you have your own network anywhere you go, and it requires very less power. So you're secure most of the times, unless somebody finds a password to that too. If it's password 123. So yeah.
Or all zeros.
Yeah, all 8 zeros. Yeah, there you go. Yeah.
Actual unironic password I got when I was in Athens.
Yeah, exactly. Yeah. So yeah.
As you were going through this, I talked to my VPN configuration that I could see in my client, and I didn't see it kill switch. Is there, how would I go and look for that feature Is it implemented? Is it assumed? Do you have any advice on like how to check your particular provider for this? Because they did not have
Yeah.
article about it.
So the thing is, like, as I said, this caused a minor panic. So everyone was asking their own VPN provider to like check if you are vulnerable to this, because like not many people understood the attack vector and the severity of it. So they just rushed towards the VPN provider. So in their forums, you'll surely find a long discussion thread on each of the VPN providers on Reddit. You could just search your VPN name and this specific CVE number, and you'll get your answer if they're vulnerable to it or not. Most of them are not. Some of them basically advise their clients to stop using their service overall. Like they didn't want to patch it, so they're just like, we're not going to do anything about it. But they eventually, after a few months, they did implement some internal security measures. So mostly it's going to be okay. You don't have to worry about it, but I would suggest like check your VPN provider's forums.
What brought you to this vulnerability?
So as I said, I work at Software Secured, and we had a client specifically ask for testing their own VPN service and they wanted us to actually test this specific vulnerability. So I had to set up the infrastructure and basically perform this vulnerability to check if they're vulnerable to it or not. And that's how I did extensive research. I got in contact with the researchers of this vulnerability, this CVE, and they also helped me out understand this attack more. And then I thought that why not give a talk? Like,
How long did this whole process take?
because I was fairly new and I was learning like tiny details on what is a RFC, what is like option 121, why does DHCP have it, what's the format of like putting all the stuff in the DHCP configuration file, around 3-4 days. Yeah, 3-4 days. Yeah. Go ahead.
So the environment that you had, that was basically, so one attacker machine, one, basically a very easy to start router.
Yeah.
And then you had a VM.
Yeah. 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 And the thing is, and one more thing is the Linux was the most affected one, because it handles its routing very differently, and there is a lot that goes on in there. And
You also mentioned that, like you mentioned Windows, iOS, and
Mac OS.
Linux. I don't remember if you mentioned Mac OS.
Yeah, Mac OS is also vulnerable to
Mac
this.
OS also.
Yeah, Android is the only one that was not vulnerable to this. Yeah. Yeah. Any other question?
Mitigations are all on the provider side.
On the provider side, or if you are in a corporate network and if you are a network admin, firewall rules, you could configure DHCP snooping. That helps as well. And if you really don't need the option 121, that helps as well. So yeah.
It's fundamentally how the networking works on each of those operating systems. It's not like it's solvable on that side.
Exactly. So this vulnerability remains there, but it depends on the implementation of your provider as well as your network administrator. Yeah. Yeah. The more you know, the better. Like this is out there. I don't think it's going to be fixed unless they cancel out the option, the RFC option. But yeah,
Fundamentally,
it's
protocol.
it's a protocol. It's a feature, right? So people can exploit that, abuse that feature to bypass your VPN. Yeah.
Sorry, could you repeat the process of starting the network to get access to the DHCP server?
So a DHCP server has a specific list of IPs that it could assign. That is configurable by anybody who owns that DHCP server. So in a router, you could just log into the router. There will be a DHCP option. It'll have a range of IP addresses that it could assign. All right. So let's say for now, we'll just take an example of 10 IPs. It could assign only 10 IPs. So what the malicious attacker or an attacker can do is they could create a bot that sends out multiple DHCP discover requests in the network, like floods the network with like thousands of them, and then gets the IPs assigned by the DHCP server to those requests. So now you ran out of those 10 assignable IPs. Now, if any other device connects to that network, they're going to be also sending the DHCP discover request, right? But there is no DHCP resource available anymore. So you stand up your own rogue DHCP server. Now it will just respond to it and say that, okay, here's your IP. It'll be connected, perfect, but you would never know, the client would never know the integrity if it's like, yeah.
You're never actually accessing the original DHCP.
You know, after, no, you cannot, yeah. Because it's about a man in the middle attack. It's a man in the middle attack. So now DHCP server is what is your man in the middle, kind of. Yeah.
Or another mitigation would be disable DHCP altogether and just go with static IP addresses.
That is possible. That is the best. That is the best mitigation. But mostly we cannot do it because like not everyone is going to statically assign their own IPs. DHCP is more like a convenient option to connect to any network without doing that. Yeah.
And a lot of corporate networks will configure the switches to only accept specific MAC addresses.
Yeah.
So if it sees a MAC address.
Exactly.
It won't allow it.
Exactly. That's what DHCP snooping is. So when you stand up a DHCP server, it's obviously going to be Linux or any flavors of Linux, and they would have a MAC address. So you could just configure your network protocols that if there is a DHCP server other than this MAC address, just don't allow it, just block it in sending any of the DHCP related requests. So yeah.
Right. One more round of applause for Harsh. Thanks so much.
I like to thank you for being such a good audience because this is my first talk and more to come. But like, yeah, thanks for being my first audience. Yeah.
To that point, the video that you didn't see.
Yeah.
Is that public anywhere? Is that something?
I could upload a better version of it. Yeah. Yeah.
We have the Slack channel.
Yeah.
If Harsh makes that video available to find out.
Yeah. Or there is a reference link. Actually, the researchers have a well-documented primer and stuff like that. I was using them as a I was using their article as a stencil to make it condensed and make you understand it better. But they have it like a very descriptive article on this. And then they also have a video for that. And then they have also done the starvation attack and everything's there. So it's the first link. That's the leviathansecurity.com blog TunnelVision. So that's where there is. And if you want to see like people screaming at each other about whether this is a vulnerability or not, that's the Y Combinator link. And there's also the GL INET link where people's egos crash and like collide and they're like, no, I'm right, you're wrong. And then there's this first guy who enters after 15 posts saying that nobody wanted to listen to me, but see, I was right. And that's, that's how it is. So I went through all of that, and then this is what I got for you guys. Yeah.
Thanks for getting through all that.
Yeah.
All right.
Yeah.
Give us a then has friends sandwiches. So if anybody is still hungry, it's not pizza, but it is successful. Thank you very much. We will be back here again in the month of November. Roughly around the middle. Watch our meetup space or our Slack channel. You'll hear all about it. Thanks again, everybody. We'll see you in a month.